Now we will go directly into our topic for the first. Okay, for this topic, okay, saya akan stop pada pukul 9. Okay, sampai mana yang kita habis tu saya akan stop, dan selepas tu saya akan record dan saya akan compile, saya akan put in the e-learning lah. Okay, right. So we have several topic outlines. First, we will look into the why spiration methods, and then we will look into the main area of spiration, common steps in the chemical analysis, definition and concepts, spiration method, and then we will do some activity in class lah kalau sempat. Kalau tak, kita pergi pada minggu hadapan lah, that class activity. Okay, and then we will go for the industrial demand current advanced spiration method. I think kalau kata kita berjaya sampai nombor 5 ni pun should be okay lah, industrial demand and current advanced spiration method ni. I don't think that we will go into detail because we will learn later on in the subsequent topic. Okay. First, why spiration method? Why we need the spiration method? Okay. Okay. It helps the chemist to analyze the substance under consideration. Okay. Kita nak tahu apa yang contohnya lah the company dia nak tahu the secret ingredient for KFC. Okay, sebab dia nak modify. Tapi takkan dia nak tanya KFC directly. So dia boleh lah analyze. Okay, untuk tahulah apa yang sebenarnya digunakan, ataupun macam kita nak tahu apa yang menyebabkan kes muntah-muntah di Sungai Kinkim. What is the causing factor? So we can use that to analyze that. Okay. And then second one is also helps to obtain that substance for use. Okay. Contohnya dekat sini. Okay, we want to create anti-diabetic punya medicine from plant. Okay, from the spiration method, kita boleh apply that particular technique to obtain that particular compound that can help to reduce the diabetic lah, untuk menyelesaikan masalah kencing manis. Spiration is also used to purify and characterize the substance. Okay, spiration used to purify lah. Contohnya you have do the extraction, and at the oil you have multiple mixture, but because it's not really pure, you want to purify it, so you can use the spiration method. Okay, you guys pernah tengok ke cerita Breaking Bad? Ada tak tengok? Siapa tengok bagi thumbs up. Best kot cerita tu. Kau tak pernah tengok lagi? Tak pernah? Wajib tengok. Okay, tapi Breaking Bad ni dia ada 18 SS sikit lah, tapi tak banyak. Okay. But most of the thing, maksudnya you tengok the few season pun tak apa, tak biasa tengok sampai last tu dia dah politik. Tapi in the first few seasons tu dia tekankan banyak kepada chemistry. Okay, so dalam case tu, okay, maksudnya bila dadah tu lah dijual di peringkat market ni, dia tak buat pure lah. So cikgu kimia tu, sebabkan dia ada kanser dan dia dah nak mati, so dia nak tinggalkan harta ke anak dia, so dia buat dadah lah. Dan dia berjaya buat more than 90% punya purity. Okay, so what interesting punya ni lah, what an interesting bagi saya drama lah, serial drama that you should not take as example, tapi patut tengok lah, interesting lah. Daripada drama Malaysia kan viral dekat Facebook tak apa-apa nak sorry lah membawang sikit. Okay, it's an essential technique industry to set standards for evaluation of other substances. Okay, nama cerita tadi, semua tahu viral tak apa-apa. Saya memang dah ban lama dah Zul Arifin ni daripada selera saya. Breaking Bad. Okay, Breaking Bad. Okay, dekat industri perlunya spiration method ni untuk dia tahu sama ada dia comply tak dengan standard. Okay, dia comply atau tidak. Okay, nanti you guys bila in 4th years, you guys akan belajar SSCC 4253. Dekat situ adalah food analysis. You guys akan belajar balik a little bit of spiration methods used for the industrial punya demand lah. Okay, kat situ banyak lagi you akan belajar akta, everything, the material, everything, a lot of things. Okay, saya tak nak sentuh in detail about that. So tak ada soalan so far? Okay, so next we go to our second outlines, which is we will look into the main area of spirations. Okay, we can divide into 3 lah. Okay, we have the analytical spiration, maksudnya you buat dekat lab. Okay, for for the what we call analysis purposes, for training purposes. Okay, and then we have the preparative expression, small scale, and then material for R&D lah, just for research and development. Okay, and then the third one we do have the industrial expression scale, which is the largest scale at all, and then it's an economical one lah. Okay, that's it for the main area for expression. It's easy, right? Okay, ada soalan ke so far? Tak ada. Semua thumbs up je. Semua tengah lapar ni. Sekejap. 8.40. And then the third outline we will go today is let's look what is the common steps in the chemical analysis. Okay, selection and preparation of sample. Actually, we have several things lah. Sebenarnya contohnya macam you determine the problem, and then you do the selection. Actually, we have a lot of things. So, but here just specifically for chemical analysis. So we need to select and prepare our sample, determine the mass or volume of sample, dissolution of sample, pre-treatment of sample, isolation of impurities of different subject. Selalunya, dekat sama ada kita akan apply lah chemical expression ni dekat preparation of sample ni. Okay. Or we want to isolation of impurities or interfering substances lah. Dekat sini pun selalunya kita akan buat dekat sini. Dekat pre-treatment pun, pre-treatment jarang lah. Pre-treatment jarang. Selalunya dekat preparation dengan juga isolation dan juga measurement. 3 ni. 1, 2, 3 ni yang akan ada separation method. Kenapa saya cakap dekat preparation method ni ada? Contohnya you bercampur different size of your punya sample. Contohnya you nak certain size. So mungkin you see first on its particular size. You tapis dulu. Okay, ataupun you just nak air sahaja. You tak nak solid, suspended solid. So you filter dulu. So you prepare dekat situ. Kemudian you nak remove the impurities. So you can do maybe from the liquid you collect, you do the distillation. Okay. And then at the measurement of analyte of interest, you want to focus on your analyte only. So you can use the chromatography, okay, to do the expression. Or you can do the column expression chromatography. Okay. Alright. So yang tu antara 3 yang kita akan guna expression method lah. Yeah. Clear ke so far? Alright. That's good. Ada tak clear, bagi tahu. Okay, number 4, we will look into definition and concepts. Okay, ini definition and concept lah. Okay, untuk expression, as long saya faham, sebenarnya kalau kata dalam soalan selalu memang antara favorite untuk kita tanya definition lah. What is the definition of, for example, expression method? So you guys need to explain. Tak semestinya sebiji macam ni, as long saya faham. Okay, operation by which a mixture is divided into at least 2 fractions having different composition. Yang ni yang panjang, yang detail lah. Kalau dia kata operation in which to separate mixture into their own components, I think it's already accepted, okay, by me. Saya rasa tak ada masalah. Okay, macam mana yang you faham dan saya faham apa yang you faham. Okay, right. So for the expression, we can classify them into several classes lah. Antaranya by forces lah. Kita ada mechanical, we have the physical means, and then we have the chemical reactions. How to do the expression. Yang ni one of the classification lah, forces. We have other type of forces lah. Other type of classification inspiration method. Okay, nanti kita akan tengok depan sikit. So analyte in mixture can be separated due to differences in size, volatility, polarity, solubility, and also ionic strength. Okay, kalau kata size ni selalunya kita akan separate guna mechanical punya teknik lah. Maksud mechanical ni maksud you kena buat yourself. Contoh je lah. Okay. Kat sini saya nak tanya lah. Okay, sini saya bagi contoh size kan. Saya bagi contoh size, contoh different size. Okay, different size. Okay, you sieve guna sieve ni lah, alat penapis untuk separate different size. Okay. Cuba bagi satu contoh lain yang guna mechanical punya forces untuk buat expression. Ya Allah. Tulis kat chat. Kat sini ada nama Zul Arifin ke? Boleh lah. Menjawab. Sial Zuarifin. Marah dia. Kalau nak aku punya besok tanya untuk jangan kelas ke kelas. Contoh lain, spiration yang guna mechanical. Okay, mechanical ni maksudnya you kena buat apply something mechanical lah. Kalau tiba tanya, okay, give example spiration method that apply mechanical forces. Bagi satu contoh. Tiba-tiba tanya dua contoh. Apa dia? Ada nak teka? Ada sarapan pagi. Oh, lamanya menaik. 8:45 already. What is the difference between mechanical and physical means? Mechanical is mean that maksudnya you macam guna you punya energy lah. Physical contohnya macam dia punya size pun boleh juga. Okay, mechanical ni size pun boleh. Contohnya macam you guna tangan untuk spray. Okay, physical ni, okay, contohnya macam different size pun boleh sebab dia the same thing. Okay, difference je cara kita spray. Okay, mechanical contoh kita boleh guna sieve kan. Okay, kalau kata size pun boleh, physical pun boleh. Contohnya macam kita guna filter yang kecil sikit tu. Ataupun satu lagi, kita boleh kata yang tak guna mechanical sangat, contohnya macam boiling point pun kira physical ataupun physical properties dia adalah satu polar, satu non-polar pun boleh. Dia difference between mechanical and physical not much different lah. Tapi mechanical selalunya memang kita kena bagi contoh yang sesuai lah. Contohnya macam you kata you spray ni using sieve by hands. Ataupun you use forceps untuk remove. Contohnya you nak remove batu daripada pasir. Maksud you use an action of hand one by one. That's the thing lah. Okay. Physical lebih kurang, tapi selalunya physical ni you boleh buat in term of lump sum together lah. Contohnya macam distillation, different physical based on their boiling point. Okay, same goes to the solubility, I think. That is for the physical mean as well. Because physical solubility also depends on the actually solubility can have different factors, I believe. Solubility can have different factors. Either it's compatible to that particular solution or the solution is already saturated or unsaturated. So it can place more than two roles lah. Yeah. How about chemical reaction? Okay, lupa tadi. Mechanical, another example, you can use magnetic separation lah. Okay, that is for mechanical as well. Contohnya you apply magnet untuk remove magnetic punya, atau you want to separate magnetic from non-magnetic material. Okay, physical means physical you tak apply the action much. Okay, you still do the action lah, tapi not much lah. Yeah. Contoh you do the distillation, but not continuously from your thing. You can rest the setup on the table and then it can perform by itself. Not many movement required. Okay, that is mean by physical lah. Okay, for chemical, sedimentation iaitu lebih kepada physical, I believe. So, chocolate is physical or chemical? Okay, chocolate circular, let me think. It's continuous. It's definitely not mechanical. Okay. Circular is the physical mean because you want to pre pre-concentrate so many times the thing, okay, by using circling distillation. The concept is like that lah for chocolate. So I believe it's physical. Okay. Right. So the next one is the definition and concepts again. Why is repeated? Sorry. Still under definition and concept. Okay, partitioning of the light between two phases while system approach the equilibrium. So we have at least two phases lah. Kalau tak semestinya you have only two phases alone tapi yang senang ceritanya between two phases lah. Okay, ataupun between multiple phases also no problem. Okay, that is for partition. How about distribution? Refers to the distribution of light into different phases. Okay, kalau kat sini kita ada two different phases, but kita tak tahu kat mana light kita. So that's when we need to know where is the distribution of our light. Sama ada it goes to the purple one or the pink one over here, or it goes to the orange one over here. That is what is the differences between partition and also distribution lah. Okay. Macam kat sini dia kata more soluble in dichloromethane. It means that your analyte is more soluble in dichloromethane, is more attracted to the dichloromethane. So it's more distributed to the dichloromethane below here. Okay. Then we have the adsorption and absorption. Okay. Adsorption is mean that this distribution of analytes on the surface, at the surface of solid or liquid interface. Okay. You mesti tanya macam mana ada adsorption on the liquid interface. Okay. Ada. Nanti bila when you guys learn at the chromatography, actually in chromatography we have the coating liquid lah on the surface punya ni. So dia akan interact with that liquid for the separation purposes. Okay. Dan ada juga yang absorption, distribution of analyte in the bulk phase. Okay. Kat sini dia tak kata solid atau liquid absorption, it can be either. Okay, tapi dia punya phase tu kena bulk. Maksudnya dia kena masuk ke dalam tu. Okay, drown into the material. Okay, so that is for partition, distribution, adsorption and also absorption. Okay. Okay, so far okay for the definition and concepts. It's already 8:52. Okay, I will try to finish 8:55 lah because you guys have class at 9 kan. Okay, and then phase contact, co-current involving, okay, any definition yang you guys akan mungkin tak nampak sekarang. Okay, you guys akan nampak in the next few chapters. Co-current involving the flow of materials in the same direction. Cross current, current button. Okay. Yang ni let me stop sharing. Let me try to where's the WebEx display settings work? Share one. Display setting. Okay. Here is the differences phase contact. We have co-current involving the flow of materials in the same direction. Later on, you will learn in the screen pointer option pen. Okay. Later on, you will learn in the CE. CE apply electric current. Okay. You have positive, negative charge terminal. Okay. So when the involving the flow of materials in the same direction, let's say the liquid. the what we call the mobile phase go to the negative one, moving over here. And your analyte, contohnya analyte you have positively charged, it move the same in the same direction. So that is what we call for co-current, involving the flow of materials in the same direction. Okay, cross current. Okay, a current of water that flows again or across the main current is mean that, for example, your analyte is negative. Okay, that but your buffer go over there. So that is what it means by cross current. Okay, and then counter current, a secondary flow that against or across the main flow. Okay, let's say you have different phases in your mobile phase. Okay, so it move. Let's say here is the main flow, and then you have the different buffer from this particular container. So it move, okay, again the main current. Okay, so we call that as the counter current. Okay, so far is that okay for the explanation for the co-current, cross current, and counter current? Semua thumbs up je. Yes, cut. Okay, it's already 8:55. So I will what we call record the rest of the slide. Okay, except for the class activity lah. Class activity I think it will be done next week. Okay. Okay, so next week kita tak ada kelas Kita tak ada kelas on Monday. Kita cuma akan ada kelas hari Selasa saja. Kita akan ambil this morning 8 hingga 9 AM. Okay. So ada apa-apa soalan tak sebelum kita stop this class today? Ya, sementara tu let me share again. Siapa yang tak sempat sign the attendance? Siapa yang tak sempat sign. Okay. Kalau tak ada apa-apa, so I wish you all the best and still maksudnya sentiasa dalam keadaan yang sihat. Okay, itu sajalah, kita boleh dismiss lah. Okay, okay, thank you everyone. Okay, I would like to repeat about the definition and concept for phase and phase context. So for the phase context, maybe I'm explain wrongly to you because because we urgently need to end the class. So for the co-current, okay, is involved the flow of material in the same direction. Let's say, for example, in capillary electrophoresis, okay. So in capillary electrophoresis, let's say, let me use the pen. Okay, let's say we have the positive and negative terminal. Okay, let's say we have the positive and negative terminal. Okay, usually for capillary electrophoresis, okay, we have the solution containing buffer, okay, that usually, okay, if I'm not mistaken, it will move towards anode or cathode lah. So it will move towards anode or cathode. So let's say the movement of the buffer or the movement or the mobile phase. The mobile phase mean that the liquid that will bring all the mixture, all the solutes, okay, that is what we call mobile phase. In capillary electrophoresis, buffer is actually that we use as the mobile phase. So in that situation, let's say the buffer is made of cations. So the cations buffer, okay, they will move toward the cathode over here. Okay, let's say the buffer is positively charged, okay, and then it move towards the cathode over there. Okay, that is what we call as the main current. Okay, as the main current. So if let's say, for example, you have analyte that has the positively charged, okay, that flow with the main current over here. Okay, so we call that as the co-current. Okay, let's say here is D and a light with the positively charged, so it will move at the same direction of the main current. Okay, right, or the main flow. Okay, so that is the co-current. Okay, in the cross current, a current of water that flow against or across the main current. Let's say you have a mixture, and then the mixture you have negatively charged. Okay, you have negatively charged, right? Let's say you have one. Sorry, can I delete? Let's say you have one with the negative charge. Okay, the compound molecule is small, not that big, so it will move faster. So it will move toward the positive. Okay, so it will move on the opposite direction. Okay, of the main current or the main flow. So what happened, that is what we call as the cross current. Okay, how about the counter current? Counter current, a secondary flow that against or across the main flow. It means that, okay, let's say you have another set of mixture that they have negatively charged, but they bigger. So when they are bigger, okay, they will move slower. Okay, so they actually act as the secondary flow. So after this, move forward towards the anode over here. This cation, okay, will move as the second flow. Okay, so that is what we call as the counter current. Okay, that's all about the phase contact. Okay, let's go to the definition and concept of separation. Okay, you have, for example, the mixture of sebatian A and sebatian B, compound A and compound B. So after the separation process, you successfully separate them into their own component. You separate the mixture to their own components. So this is the concept of separation. Okay. Alright, let's look at the outline number 5 for the first chapter, which is for the separation methods. Okay, so here is the example of we apply mechanical driving force, okay, to separate the thing lah that we want to separate. For example, kita ada beras dan juga hampas gandum. So through the mechanical action, repeated action, okay, so we can remove the hampas, okay, from our rice grain. Okay, so this example for the mechanical winnowing, what we call the process of winnowing. Alright, now let's look on the next pressure methods. Okay, it's actually under physical. Okay, last time I explained to you it can be either physical or it can be either mechanical if you're using the sieve. Let's say if you just want to separate between solid and liquid using the sieve, then it should be a physical one lah. Okay, because you don't perform a lot of action. But let's say you have large grain and smaller grain, and then you need to shake it a lot of time, so it can be mechanical for this one. Okay, if you look over here is the other separation method, distillation, that also using physical properties including the boiling point. Okay, here another physical properties depend on the size of material. Okay, the one that is not able to be have high size, okay, larger size, so they cannot pass through the filter paper. So that is what we call physical, because we spread them based on their physical properties. Okay, right. How about this one? Okay, so it depends on what we look here. Okay, so if you look over here, that oil and water, they have different chemical properties. Okay, if the separation based on the chemical properties, how they react with each other. For example, the one is polar, the one is non-polar, because of their chemical structure or their chemical interaction, then we call that as the chemical driving force or chemical reaction, or maybe your analyte is more soluble towards oil, or so we call that the separation method through the chemical reaction. Okay, right. Right, let's look into detail. Okay, classification, separation method can be classified by driving force. We know that we have the mechanical, physical, or chemical reaction. Okay, under these mechanical, physical, and chemical reactions, we can also divide them into equilibrium or kinetic type of driving force. Okay, if it's equilibrium, which means that they need to reach the equilibrium with certain phases so that they can start to separate with each other. For example, in chromatography. In chromatography, alright, let's say this is the column. You have the column, and then they actually, your analyte is in contact with the surface side, or we call that as the stationary phase. Stationary phase. Okay, when it comes into contact with the stationary phase, do some kind of what we call absorption, okay, and then reach the equilibrium. So that is what we call as the equilibrium. Okay, same goes about distillation. Okay, you reach the equilibrium at certain degree. For example, the temperature, your analyte is at 60 degrees Celsius, the boiling point. At 60 degrees Celsius, it reached the equilibrium state. Okay, for it to be change from the liquid to gas, so that is the example of equilibrium as well. Okay, same goes to precipitation. After you reach a certain concentration of reaction, okay, certain condition, and then it can form precipitation. But for kinetic, it needs movement. Okay, like dialysis. After dialysis, okay, let's say this is your hand. I'm not good with drawing. Okay, this is the tube of blood. Okay, and then it will move over here. We have the filter. Okay, so we have the diffusate and also residue. Okay, so it is through the kinetic action. So it's through movement. Okay, for example, here the next one is the centrifugation. Okay, centrifugation. The one that has higher density will move towards the bottom, and then the lighter the density of the material, they will stay at the top of the liquid, okay, or top of the mixture. So it's through movement. Okay, so this is under driving forces. So again, driving forces, it can be either mechanical, physical, or chemical reaction. Okay, under all these three, okay, we can have also the equilibrium type of driving force or kinetic type of driving force. Okay, let's look on the next one is the separation methods that we can classify by operational aspect. Okay, here we have the analytical separation techniques is either batch or continuous. What is the example of the analytical separation technique by batch? For example, we perform using filter, okay, using sieve, okay, filter or using sieve, or we can use the liquid extraction. Okay, liquid extraction is mean by batch. Okay, you cannot do it continuously. Okay, so by batch, the detection is offline. It means that you cannot put the detector, it means that you cannot automate the system. You cannot automate the system. It means that after you use the filter, after that only you can dissolve, and then you go for the analysis. For example, let's say using UV, or let's say using HPLC or using FTIR. So you cannot automate them. Okay, how about continuous? Continuous is a process that you can actually make it automated or not lah. So it can be non-chromatographic, and it can be chromatographic. Okay, continuous is mean continuously separation, not by batch. Okay, alright. So for example of continuous analytical separation method, okay, which is non-chromatographic, is the distillation process. or maybe chocolate. That is the continuous. Okay, non-chromatographic, it can be either automated for detection system or not. Okay, for example, the non-chromatographic, okay, then offline we can try non-chromatography offline, for example. Yeah, after you do without the automation, okay, you need to separately submit for example, for UV base. Okay, for example, you want online, you can automate the system at industrial scale after the distillation process. Okay, and then you can submit for test over there. You can put the detector over there, and then you can detect either it is reach the end product or not. For example lah, you have already know about how we can produce the petroleum, okay, from crude oil. Okay, that is one of the example of the continuous, non-chromatographic and online system. Okay, how about continuous chromatography? Either is offline or online. Okay, I give you an example over here. Continuous chromatography offline. Okay, for example, column chromatography. It means that you cannot put over there at the end of the column the detector. You can search by yourself column chromatography. Okay, how about the continuous chromatography and online? So we have a lot. We have the HPLC, we have the GC, whereby at the end of the system of separation we have the detector. Either it's UV or either it's FID, either EMS or either it's ECD. So we have a lot of chromatography online. So that is the classification by operational aspect. So you guys need to be able to understand, okay, and what kind of the analysis, okay, you can do for each operational aspect. Alright, so let's look on the last classification method, which is by the type of phases, right? So in the separation method, we can have two different phases. Okay, usually for separation, we usually employ two different phases, which is we have the initial phase and then we have the second phase. Let's say one of the phase, okay, is a gas, and then the other phase, second phase, is the gas as well. We do thermal diffusion type of separation. Okay, so we can use thermal diffusion type of separation. Okay, then let's say you have the first phase is gas and then the second phase is liquid. Okay, we can use the gas liquid chromatography. It means that the sample is in gas form. Your stationary phase is coated in liquid. So your analyte is in gas form. They will interact with the liquid stationary phase. Okay, for them to be separated. Okay, right. How about gas as the initial phase? Okay, and the solid as the secondary phase. Okay, or we can call that gas is the mobile phase, and then the solid as the stationary phase. Okay, so if you do over here, it can be gas solid chromatography. How we can what is the type of the instrument that use gas solid chromatography? Is gas chromatography as well. It means that in the column of GC, it has the particle, solid particle that will react, okay, with the analyte of interest. Okay, okay. The what we call the mechanism is about the same with the liquid. Okay, so liquid, let's say the initial phase is liquid, the secondary phase is gas. So you can do by using distillation. Okay, so if the surface phase, okay, is liquid, and second phase is liquid. Okay, we have a lot. We can do liquid chromatography, we can do liquid extraction, dialysis, or ultrafiltration. Liquid solid, okay, it can be liquid solid chromatography. Liquid chromatography is like HPLC. Okay, HPLC is the same. The column have the particle that coated with the liquid. If liquid solid chromatography, it means that the column have the particle, okay, the adsorbent over here, or absorbent without coated, without any liquid coating. Okay, so we call as that as the liquid phase and also solid phase. Okay, so we have a lot of example over here, right? And then if the initial phase, okay, is the solid, and then the second phase or stationary phase is the solid, okay, it can be either sublimation, okay, sorry, solid to gas, okay, from the solid directly to gas. So they, what is mean by sublimation is that they don't have that intermediate phase. So solid directly go to the gas. What is the example of solid turn to gas? Okay, for example that I can give you is dry ice. Okay, for example, you buy the dry ice, okay, then if you pour warm water over the dry ice, even without you pouring the warm water over the dry ice, you can see some kind of asap lah, okay, some kind of smoke produced. It means that is actually the gas of carbon dioxide produced. Okay, so that is what we call the separation of solid and gas phase. Okay, so there are two phases over there, right? So solid and liquid, we can do zone refining or leaching. Okay, zone solid and solid, we can do zone electrophoresis. Okay, okay, the next one we have how to choose the separation methods. So it depends on the type of mixture do you have. So it's not necessarily here you need to follow exactly what is suggested here. So whatever we have here, actually you can suggest more. For example here lah, for example you have the solid mixture containing magnetic material. Okay, you can separate them by magnetic attraction. If let's say for example solid mixture, it is solid mixture but doesn't have magnetic material, how to separate them? So you need to separate them based on their density, for example, or maybe you need to separate them based on their sizes. Okay, so that's why I'm saying it's not necessarily it's limited to what is actually printed over here. Okay, so you need to think carefully, okay, and critically lah. So let's say you have the mixture is solid liquid mixture, okay, and then you have the insoluble solid. Okay, so you can easily separate them by filtration. Okay, but for example if you have the solid liquid mixture and then you have soluble solids, you need to do other thing. For example, the one that do not decompose on heating, you can do evaporation lah, so you don't have the problem with the heating. What you mean by decompose, you mean that the compound doesn't turn into something else. Okay, so do not decompose, doesn't break, okay, if you apply any heating, right? So you can do evaporation. Okay, so let's say for example you have A and B. Okay, A and B. B, you want to collect A at 70 degrees Celsius, the boiling point. Meanwhile B at 50 degrees Celsius. So you want to collect A, so you can do the evaporation at 50 degrees Celsius to remove B. Okay, so that is the situation where, for example, your compound is do not decompose on heating lah. Okay, let's say the compound is decomposed on heating, you need to do some of the chemical reactions so they can form the decrystallization. Okay, then the next one, if let's say you have the liquid mixture, okay, as you can aspirate it into liquid and its mixture, you can use the distillation. Okay, different liquids and their mixture, you can do fractional distillation, or you can separate them into different colored component chromatography. Okay, so a lot of things. Okay, if you look over here, if the mixture is liquid and is mixture, you can use distillation. What is meant by liquid and mixture? For example, you have three components, A, B, C. You want to separate A only. A is at 60 degrees C, B is at 80 degrees C, and C is at 100 degrees C. So you apply distillation at about 60 degrees Celsius. So you can separate A, and then let's say you do the distillation. At end of distillation, you collect A, and then over here at the heating, okay, you left with B plus C lah, because you apply heat at 60 degrees Celsius only. So that is what it mean by separated into a liquid and its mixture. It means that you target only a group of analyte while you left the others together. Okay, so you need to separate different liquids and their mixture. It means that you have a lot, A, B, C, D. So you need to do fractional distillation. For example, D at 100 degrees C. It means that you perform for A first. Okay, after A is finished, and then you do for B. After B finish, then you do for C. That is what we call fractional distillation. Say you go one by one. Okay, and then you can separate them into different color components. It means that you want to spread them all together at at one time lah. Okay, it means that you have three component, and then after it's enter the column chromatography, and then they have different reaction with the stationary phase. So let's say the rectangle one react stronger. Okay, the triangle one react mid, and the circle one doesn't react at all, so it will move faster. Okay, right, so the circle one will reach the detector first, followed by the triangle, and also last one followed by the rectangle. Okay, so depends lah, depends. Okay, we're supposed to have the class activity, but I think I want to discuss with you during classes lah. So how to separate mixture based on three mixture lah. How to spread them. Okay, what kind of the technique that you can use. Okay, so you need to identify the mixture, and then you need to identify the separation method that you can choose. Right, so we will wait for next week. Okay, so let's go to the 6th outline. Okay, for this topic, which is industrial demand. So I don't want to touch a lot. So it's not updated, but I want to show you guys the trend that the industrial demand on the chromatography or the separation is increasing. Okay, increasing. Okay, if you look over here, a lot of industry need a separation method. For example, independent testing lab. Okay, they want to test either, for example, what kind of the amino acids in their product. For example, what kind of vitamins, okay, nutrients that do have in their product. So independent testing lab. Government, especially for example, Jabatan Kimia Malaysia, to test either for example lah, drive under influence. Okay, drunk driver kill somebody. So the government, okay, under Jabatan Kimia Malaysia, will do the analysis. Academia like us, not like you lah, not really sure. Let's say for example, in the future you want to be a researcher in academia, yeah, of course we use a lot of the separation method. Pharmaceutical, you want to look at the drug. Organic chemical, how to purify things. Biotechnology, how to deliver, for example, the medicine. Agriculture, to look at the poisons. Okay, how to look at the fertilizer. Okay, and then we have a lot of other things. Okay, hospital, polymers, environment testing, petrochemicals. If, for example, in your final year project, you can get a hand on gas chromatography, especially gas chromatography, mass spectrometry, I believe that will be what we call become your good arsenal later on during your employment. Okay, my students, a few of my students that actually have experience using GCMS, Okay, they don't have any problem at all to be employed. Okay, one of them successfully what we call get employed in the Top Glove company because he has the knowledge how to use HPLC and also GCMS. So if possible, you can get your hand on the GCMS and also the HPLC, go for it. Okay, go for it. So the last part of this topic is the current advanced preparation method. I don't want to touch a lot into this thing. Okay, you guys can Google by yourself because later on, during subsequent topic, at the next topic, we will touch a few other advanced methods. So I don't want to discuss in detail, just want to show you. Okay, we do have magnetic aspiration, electrically driven aspiration, microaspiration, liquid membrane, chromatography aspiration, lab on chip, and so many others. Current advanced aspiration method is a good. It doesn't mean that I don't say it's not good. Okay, but a lot of them is actually has not been what we call used as the standard method lah. Okay, because they are still new. Okay, but they are promising. Okay, they are new but are promising. Okay, right. If let's say in 2000, in year of 2000, the most famous method of aspiration, LLE. Okay. In 2010, okay, or maybe 2005, 2010, they start to employ SPE as one of their standard method. In recent years, they love to use SPME. Okay, at least. Why is that? Because they actually improve from the previous version. LLE use a lot of solvent. SPE minimize the amount of solvent. SPME, okay, SPME use very minimum solvent, but of course the SPME is much more expensive. So a lot of the methods, okay, that's why people saying that science never complete. Science is a continuous process of development. Okay, so I'm not really sure in 10 more years what kind of the instrumentation method that will be employed as the standard method. Okay, right now we have the lab on chip, kind of famous study have been done all over the world nowadays lah. Okay, in UTM, I believe Dr. Si Hong Heng, okay, Dr. Si Hong Heng, PM, Professor Madya, Associate Professor Dr. Si Hong Heng is the most expert one lah currently in our department. Okay, for me, if you're asking me, I'm still using the microaspiration lah. I'm not going to lab on chip lah. I'm more into microaspiration. For example, I use the micro aspiration of LLE, okay, as one of the common method for my study. Okay, right, so many others you can read by yourself. So here is a lot of technique, lab on chip, everything. I think that you can read by yourself. So you need to know, or here is another example, SBSA, stir bar sorptive extraction method lah. It means that we have the stir bar coated with the magnetic thing and also their adsorption or absorbent, okay, at the outside. Then you put your sample over there, and then you run, for example, 20 from few minutes to few hours or a day, and then you can extract everything to the absorber, to this bar, okay, and then you put in your solution to dissolve all the targeted analytes, and then you can do analysis using GC or LC. So it's quite famous in 2000, starting from 2010 lah for the development, but until today there is no movement to adopt SPSE as the standard method lah. Okay, as the standard method. I think because of course, I'm not really sure in the future how this progress develop. Okay, science is a process of development actually, right? So here is, for example, the LLME, okay, the micro, so a lot of things. I think you can search by yourself. That's it, I think. Okay, for the first topic. Okay, see you guys next week. We will do the class activity. We will have some discussion. If you have any question, we can try to discuss together, and I will try my best. Okay, if I'm not able to answer your question, maybe we will take in another week. I will ask my friend, I will ask my colleague, and how to help you with your question. Okay, that's it, I think. Thank you so much.